Before we start, for those that are sitting here, does anybody have any common obstacles that keep them from advancing their process? People. People is the number one reason. There's other reasons. There's financial reasons. There's cultural reasons. There's mentality, company philosophy, resources. There's a lot of obstacles that we can accept that we allow to hold us back. But knowing the tools that bypass these obstacles or get away from it is kind of the key. So, my goal isn't to sit up here and tell you all this great stuff about Blum. There will be some stuff about Blum. My boss is here, so I'm obligated to do my job. But I'm going to kind of go through some other topics as well. So a lot of people ask early on, who is Blum? What is Blum? What do you do? Why you? And I don't focus on our what, because everybody that is currently in this tough business of manufacturing has a very good what. So I'm more focused on the who. Who are we? What do we bring to the table? What value do we serve? So just a little bit of background on who Blum is. Very well-established company, based out of Germany, 56 years in the industry. Machine tool design company that said there is a better way to do metrology inside the machine. So very high scale look at who we are. We are not a hardware distributor. We try and be a solutions provider. We try and be a partner. We have a lot of interesting feathers in our caps that are not metrology related. The founder of our company invented the umbrella style tool changer for Stama that went to robo drills. So that is the level of design engineers that Blum started with. And, you can fact check me on it. It's patent number 4103405 in 1979. And again, we don't want to be a vendor. We want to be a partner. There's a lot of companies out there that are willing to ship you a box of hardware, and that's not us. I mean, when people ask me, hey, I want this laser, I ask questions. I don't put it in a box and ship it. And if that's what you guys like, then, Blum may not be your cup of tea, and that's okay. Again, we are a global company. We have a strong presence in North America. But just to get into a couple points of what we do, there's traditional tool measurement. We offer in-process laser measurement, tactile tool measurement. There's a lot of different good tools out there to measure tools. And none of these solutions are wrong. There isn't a right and a wrong. None of them are obsolete. All of these still serve a purpose. And I will go through a couple slides of just why I think Blum is a great option. A little bit of a history of the Blum laser. Blum invented the first in-machine tool measurement laser in 1987. It was gas-powered, it charged up, and it shot a beam through the machine envelope, and you better hope your tool was there to be seen. Otherwise, you're waiting again. But this product has evolved. We can go 2 meters between transmitter and receiver and still measure your tool in a very high accuracy quality, where we live in the world of microns, not tenths or thou. And again, now our latest laser we released in 2017 is the LC50 Digilog. Very interesting product. And that always goes into the next question of Digilog. What is it? Why is it different? Why should we use it? Why should we pay attention? There's this big push that digital is the answer. Get away from that old technology. We found that the combination of both of these two communication protocols, these data methods, were relevant. So we don't want to just enter and exit a beam and measure a tool. We want to dwell in that beam and gather hundreds of thousands of measuring values per second, as opposed to, is it a 1 or a 0? Am I breaking the beam? What is it? So we've developed this technology, and it's just what we found to be the most stable way to measure a tool inside of an environment with dripping coolant, sticky chips. It's a tough hurdle to overcome, but we have a very nice what to overcome it. Again, just a little explanation of the digital and analog. Digital, one trigger. Analog, we're shading and we're collecting data. What that means for you is just the traditional method of digital measurement is you find the edge of the tool, you break the beam once, you break the beam twice, you break the beam 3 times, and we give you diameter, length, whatever it may be. This was the best way at the time to do it in the industry, but it was a cumbersome process. It was slower than what was accepted, and it seemed to be reserved for, I'll let the advanced manufacturing people do that. They make high-end parts so they can justify this cycle time. What we did was, now we still have that search function, but instead of entering and exiting the beam multiple times, we do a search, a fine search, and then in 8 revolutions of the tool in the beam, we've gathered enough data to tell you geometrical value of that tool, length, radius, if a flute is chipped, a lot of information. Just a little bit of visual on how much faster it is. A quick little side-by-side video. Does not want to play because it goes to my solid state. So we're going to skip over that. Moving on quickly to some more features that we offer is touch probing. Touch probing is becoming more and more necessary. As Nathan mentioned, we want fingers off the control. All of these things are still valid ways of measuring. But again, there's no right, there's no wrong. We just have our way of doing things, and we think it's a good way of doing it. Nobody buys a CNC machine thinking I can't wait to measure my parts. So we understand that we're not always a fun decision to make, because now I'm buying a machine tool to measure parts, but I have a piece of equipment that measures parts. I'm wasting time, and I would never ask you to measure every part, measure every feature, but there's critical features that make us a necessary evil. And I don't like to say it that way, but I mean, a necessary evil, you have to have part quality. And our philosophy is, if you have to do it, you should be able to do it as quickly and reliably as possible. So again, coming from the machine tool world, 400 millimeters a minute probing speeds doesn't cut it. We probe at 3,000 millimeters a minute. 2 touches, spindle orientation doesn't cut it. We are 1 touch, moving on. It's a non-mechanical trigger. We can't have wear. We have to have a wear-free trigger. We developed the laser, the same principle as in the probe. A pin breaks a light barrier. We can't have mechanical contact that wears over time, because the same feature will now have wear like a tool does. We have the big onslaught of product, just like everybody else. It's a broad product offering. And the major difference is just where we come from. We manufactured it for the CNC machine. We didn't adapt technology that existed and said, man, we can make money by putting it over here. So again, it's a cultural difference. It's a mentality of how would we do it? Not what can we sell or how can we make money, but how would we do it if it's our business? So again, it's a broad product line. Everything's IP68 rated because we want you to clean your part as you probe it. So again, very, very different philosophy, different mentality. And that is really the only thing that you should be concerned with. What makes Blum different is we want you to succeed. I don't want to send you something and you don't enjoy it. That's my fault for not doing the legwork on the front side. Again, we'll skip over a couple of these videos. because I don't think they'll play. Nope. So the biggest question is, what is advanced manufacturing? I think we were so premature with this launch of Industry 4.0. I think it's a great idea, but we didn't have all of the tools to really understand it. And people say, hey, what is advanced manufacturing? And I say, I don't know. So the only thing I know is that I am a small piece of the puzzle. You know, you have to understand that you have an offering as a company that sells machines, makes parts, sells probes, sells lasers, that you're just a piece. You don't have every answer. So I feel that what I offer in conjunction with other offerings is really what takes people to the next level of manufacturing. So the biggest question, and this is where I wanted to focus a lot of my time, is, okay, well, how do I get there? And I'm not sure if anybody's heard this phrase, but I've been kind of hearing it thrown around a lot, is data is the new oil. You know, data is the most important thing that we can capture. And I think there's a lot of people out there that will say, I can give you all this data. And I would kind of call them them. You know, yes, they can give you data. But then there's companies like, you know, Bloom and Karen and all these other vendors that are out there that I like to kind of consider an us, where we give you data, but we don't tell you what data you need. That's I think the biggest sticking point. And it is impossible to manage what you can't measure. If you can't measure it, you can't manage it. If you don't know about it, you can't fix it. So what data do you need? And just to kind of keep the analogy going with data and oil, I find data that is offered by the majority, which I would call them, is this crude, unrefined oil data that is not useful. It's a bucket of mixed up Legos. I have a couple kids that they are an us and a them. One is I build things, the other is I break things. So it's a big contrast. I'm not a Lego player. I'm probably the mixer upper guy, but so there's a crude and unrefined version of data that a lot of people will give you. And I feel like we are more of a us. What we do is an us. We give you this data. You tell us what it is, and it's the pile there, but then we take it and we do something with it, which I think is the problem. People collect data and it's their data that they have, but what do you do with it? So what I like to say, the offerings that we have quantifies it, it sorts it, it arranges it, it visually presents it, and then ultimately it makes it actionable for companies. And, Nathan talked about it. You have to know these things, and people aren't going to willingly admit their mistakes. You find out about it and it kind of stinks. So that is the two different offerings that I see is very predominant in the industry, of people thinking 4.0 is something that it's not, and telling you that they can get you there. But anytime, in my mind, if I hear somebody say, I have all the tools, it makes you very skeptical at first, because I don't think one sole provider can give you everything you need. So, kind of stepping into advanced manufacturing, how do I do it? I think there's a lot of good answers to that question, but again, understanding that it's not just me, it's, Ryan over at Omega, it's Rob, it's Nathan, it's Heimer, it's all these tools are a piece of a large puzzle that it's vendors like myself. It's my job to not just talk about, hey, look at all this cool Bloom stuff, but there are other offerings out there that in conjunction with mine can really help you out. And not that these standalone pieces can't help you, but they can't they treat the symptom and not the disease, which is a inherent flaw in manufacturing. We want the quickest Band-Aid to get past the issue we see and move on. But again, I think it's finally at this super exciting time in manufacturing that all of these tools and assets are now becoming available for all of us to see how they work, to have references of who does what and how it works. And again, it's up to vendors to share that with their customers, to not just be that machine tool sales guy or laser sales guy that gives them this thing, appeases their boss, and moves on. You know, we have to think of ourselves as a resource, and we have to have a passion for manufacturing, because when it grows here, it transitions. It's such a tiny industry where everybody knows everybody. You can be in a different state and see people you know. At these events, you see a lot of the same faces. But again, just an idea of how to get there. There are processes, and this is a touchy subject for me because we are constantly pitted against, why would I measure my machine or my tool in the machine? I put it on my Omega presetter and it comes off dead nuts. Sorry if that's inappropriate, but it comes off with high accuracy. And it's a very clear answer that tool spinning at its nominal cutting speed does not look like that. But this tool gets fingers off the control, and that should be our goal. 7% mistake rate is alarming. It's alarming, and it's not our dad's. My dad's manufacturing at Cummins, and he says, this process doesn't work. I still get my notepad down. I've had him take Nathan's test, and I had a good laugh. He did not, but it makes some validity behind these things. So am I a competitor of a tool presetter? I am not. I am different. I am in conjunction with. Use that before. It is a valid tool. The laser. If your tool cuts at 10,000 RPM, measure it at 10,000 RPM. Maybe you have Z-axis suck up, and now your tool is shorter than what it said on the tag, on the chip. Update that tool. Then after cutting, measure your part. I don't want 100% inspection, but measure your critical features. It's seconds. We live in seconds, not minutes. We are a fast probe, measure the parts, get it back. After you do all that, you have your laser preset data, or your preset data. Now you have your laser data that updated that tool table. Get that data written back to the tool so it can come out of that machine, or operator A has a tendency of unloading a tool and taking it to a different machine. Know how much life is on the tool, know the geometry, know the wear, know the state of what it's doing, because operator B is going to pick that tool up and say, yeah, it looks good, run it. And now you have a hiccup in your process. And again, I don't think this is not the answer. I'm not saying, here's your answer for advanced manufacturing, but this is a step in the right direction. And it's all of these tools. So again, we just got to kind of sit back and not have this mentality of it's me versus somebody, or I compete with them. It's all of our products serve a purpose and have a place. Again, just a little bit of a flow here. You have one last piece of the puzzle. You have all this information, but Nathan's software that he showed, you have to somehow present this visually, because you can't have 30 pieces of paper that you have to flip through to figure out, okay, why did the machine crash, or why is the machine down? Well, let me look at the tooling data. Oh, I got to go here. You have to have this, and I'm not saying, sorry, Nathan, that this is the only answer. I'm not saying that's the only answer, but this is you have a perfect opportunity to see if this is your answer, and you don't have that opportunity every day. We're small companies that cannot be at every facility. Our job is to educate, but you have a unique opportunity to see how all of these tools can be sent to a database, to a software management tool that now presents it visually so that it doesn't take a data scientist to interpret. Operator A looks at it and says, yep, red is bad, green is good, we're good. Or my phone made a ding noise. What was it? Oh, better go change a tool. So again, we have all of these tools that on the surface people say, man, can't believe that guy's talking about that. But there are valid arguments behind why you need all these things. But again, the biggest thing I wanted to kind of leave with is you can't manage what you don't measure. And a lot of people don't want to measure statistics because they don't want to know how bad they are. People want to high five and say, we did great, look at how great we are. But again, we have to have systems in place to take it and make this data actionable. The industry is really kind of pushing everybody to be better. The days of the handshake, Mr. A, you'll have my business forever. Those days are gone. You have to be proactive to not give your customer a reason to shop your quote, to pit you against somebody else. So to be on the proactive side, to show that you use these tools, that you have this desire to improve your process, and it's not the handshake agreements that we live in anymore. I mean, we have to stay competitive in this market, and our goal with the tools we offer is to keep cost per part low and make our customers competitive. So there's an investment from both sides. So that is really like my maze that kind of came out through PowerPoint of, I think there's a lot of gray area and people are leery of talking about it and they don't want to know about it. They don't want to know how bad they are, but manufacturing is in such a unique spot that can take us, my kids, I have 2 boys that are 10 and 7. I would love for them to get into manufacturing. I think it's the coolest thing. They want to, be in the NFL, probably not in the cards, but I bet you can be a machine operator, and it's a super cool job. But again, I think we need to invest into the future of manufacturing, make it personal, make it actionable, and share each other's information, share each other's successes, and not worry about, I may not get that sale, because really, if we're doing it right, we all are a manufacturing family that kind of succeed together. So we're really reliant on each other for success. None of our companies are big enough to promote to every job shop, every big shop. And that's really again, kind of the maze that was in my head that came out on paper. And I'd just like to, quickly close up again, thanking everybody for coming. I have some space in the back. If you want to come chat about anything, I'll be here all day. But again, do yourself a favor. Take a look at the facility. Take a look at the other partners, because they have some really, really cool stuff. And I would like to go eat some barbecue now.